So a bit of historical context before getting into what Magicbeam is and why it was kind of created as part of our work. So I don't know if you've heard of a product formerly known as CodeTweet. It was designed to allow enterprises to share their Twitter account amongst themselves. So the backstory here is, how do we retrieve users' social media data? So the first step was a Ruby cron job, and everyone can probably imagine how well that worked out for us. The second incantation was a non-OTP Erlang daemon. We affectionately called it Nomura, although I believe it was Christian who named that. Worked out much better than the Ruby. The current incarnation, it's a distributed Erlang system via RabbitMQ, pretty much OTP. I think everything other than the release upgrades because they still give me a bit of a headache. One day I will figure them out though. So what is a Nomura? Large jellyfish, the largest cnidarian in the world. Kanji, I believe, for field village. Or for us, a distributed platform providing social data streams throughout the exact target software ecosystem. So just internally for us, it pulls stuff from Twitter and Facebook. Going to be mixing in some others eventually. And there's multiple components, including scheduling, API workers, data workers, and some command and control nonsense, which has partially been brought out into Magicbeam. The important part is the workers in the context of where Magicbeam came from. So how do you make a worker pool? This seems to be kind of a underlying theme for Erlang developers. How do you make pools of workers? We had 3 key requirements. We had to be able to dynamically adjust these pools of workers up and down to deal with ever-changing circumstances. So adding more users, database problems, life in the cloud is fun. Also, faults isolated between individual requests and customers. If one customer is having problems, we don't want it to be affecting others. And transactional / stateless. So in every given step of our kind of event feedback loop, we want it to be completely transactional. There's no, if something happens in one part, it's not going to affect another part. So all of our workers, they wrap a RabbitMQ or AMQP consumer. And the fun part here was finding a supervisory structure that fit. So chaos beams. Who's familiar with Netflix's Chaos Monkeys? So for those who aren't, I see a few hands, that's cool. They actually have a whole simian army, but the relevant part here is the Chaos Monkeys. And this is something they use to kill off random EC2 nodes. So you can probably see where this is going. How better to test your supervisory structures? Or, cause mild concern in the QA department. So in principle, what this does is, what happens when we kill off random Erlang processes? They are supposed to be supervised, right? That's what we do. Simulates, unexpected function calls, unexpected inbound messages. I call these typos sometimes. Unit testing can, of course, help a lot with this. It's not really doesn't save against everything. So there's the fine line between not handling common errors and matching all the catch patterns, every single one, which is something it happens sometimes. I mean, we're all guilty of it, I'm sure, but not very OTP in the letting it crash sense. So who supervisors these supervisors application masters? In theory, it's Thunderbeam. So tunable timing of process death. What does this mean? Every now and then, it's going to kill a random process in your Erlang VM. Of course, there's a blacklist of registered processes or OTP applications to not kill. Hard-coded into this is application master, because you could probably imagine what happens when that gets killed. Unsurprisingly, Amnesia is very easily upset. So we don't actually use Amnesia in our code base. It's used, I guess, internally in RabbitMQ. But yeah, generally killing off any part of an Amnesia application will end poorly for the system, and I hope you have a VM heartbeat. So we have a gen server handle info handler. It's just a little include macro you can drop in at the end of your handle infos for handling the killing of a trap exited process. It just simulates a crash. It returns with a non-normal, non-OK status. So if you want to still simulate what will happen if one of your trap exited gen servers blows up, you can still do that. You can also force kill supervisors in non-OTP processes. This was originally done for us so we could actually kill off the supervisors themselves, because those are unsurprisingly designed quite robustly. And if you have a multiple tiers of supervisors, you might want to know what happens if the one in the middle goes down. So second part of Magicbeam is, hot-loaded beams. So jokes aside, it's one of the, to me, one of my favorite parts of Erlang, where you could just reload the code on the fly. It's kind of magical. So waiting tends to be kind of boring. We don't really have the sword fight excuse anymore. I don't know if any of you recognize that XKCD cartoon. Why are you guys messing around? Well, the code's compiling. So no more excuses in that context anyway. So hotbeam, it'll reload the module if the beam file changes on disk. So really, there's nothing new here. That's something that's been done in other projects and released. What it also does is it'll recompile if the source file changes. Hadn't seen anything out there that does that watches it. And it seems to work. And in this extent, we finally caught up with PHP. You can change a file and save it and test it right away. You don't have to wait for a compile. And admittedly, compiling in our project got a lot faster when we switched to rebar from scons, but it still took more than an instant. So in action, hotbeam extrapolates your source file from the code metadata. It also pulls out the include files. I think those are the only two things it pulls out. You can control which OTP applications are monitored for change. So you don't necessarily want to reload everything, and chances are you don't have, or actually maybe you do have the source for OTP just lying around. Can selectively enable and disable the automagic compilation and reloading. These two are not, inclusive. You can have it just reload the beams on change, or you can have it recompile and then reload the beams on change. And there's manual control of this. So you can have it running in the background, paying attention to which files have changed, and say, oh, I actually want to reload this OTP application right now. Although I guess a caveat to that being where it'll only actually reload the beams. It won't recompile the entire application. So a few things where hotbeam could be better is support additional file types. Number one on my list is early DTL files, because those are kind of awesome, and it doesn't support it right now. Monitor the header files and recompile all the dependent source files. So these are both things which, in theory, I can do based on, or another open source contributor could do based on the metadata available in the files right now. And a code change callback to support runtime state changes. Right now, there's kind of a hackish way of doing that, where after reloading a beam, it tries executing a module or a function called hotload/0 in that module. And that can conceptually call into a gen server and do a code change or whatever. I think the only place I'm actually using it is for reloading, legacy early DTL templates from before we were using rebar to automatically compile those for us. So REPL for all. And I guess, is there anyone in this room who doesn't like runtime introspection? Raise your hand if you dare.
I'm the Devops tribe.
Right. So I guess a bad habit of mine kind of is a manual implementation of info/0 functions on just about anything that's wrapping a process. It's a little easier than sysget status. It returns just the information I care about at that moment when I'm trying to figure out why something's on fire. A cultural tendency within ExactTarget towards live configuration changes. So we use application environments, but also depending on who we're being rate limited by conceptually, adjusting various configuration and scheduling values. Tend to over-engineer configuration logic, and this is where this aspect of Magicbeam came from. So essentially trying to give manual control of these running systems, and not everything is going to get a web interface. Exposing web interfaces to ops is great, but you don't necessarily want to give them fine control over every single piece of a running application. And it's friendlier than the typical Erlang shell. And going back to the context of giving access to ops, it's less dangerous than the average Erlang shell, because you can't just delete arbitrary ETS tables. So in principle with Shellbeam, it's giving a simple behavior for implementing a bespoke and easy-to-use REPL shell. So very simple. It's parsing strings and executing functions that you tell it to execute. Abstraction around logic with runtime help. So as part of defining these functions, you also define their syntax and what it is they're supposed to be doing. Hierarchical subshells with shortcut access, so you can have one shell open another for a specific task, or just do a shortcut into that hierarchy, that subshell as well, depending on what it is you're trying to implement. So in terms of Shellbeam in action, as part of Magicbeam, it has an implementation for this. It exposes some basic Magicbeam and Erlang functionality as the default callback. You can remote into a node. You can open the actual Erlang shell. You can enable Thunderbeam, hot load a module, nothing too fancy there. There's also a subshell for editing the application environment for any OTP app. So it's kind of a shortcut into that, being able to tweak runtime configuration. This Shellbeam, essentially REPL shell, it's parsing whatever you're giving it, strings, and passing it into a callback implementation function. And also, it integrates the SSHD support. Anyone here mess around with the Erlang SSHD client? Okay. So basically what this does is it starts it for you and generates your host key. You still have to generate your authorized key file. I was going to not include a code sample, but I'm sorry. This is what I know it's kind of small, I guess, but this is a sample callback for Shellbeam. So this is the application environment editor. The only thing required by the Shellbeam behavior is a function called commands, arity of 0. And this is a 3-part tuple. The first is a list of tokens that it'll match on. So this first one for listing, it lists loaded OTP applications, a list with just the one string in it, list. And then the fun to actually execute. So in this case, it's a fun that's going through your loaded applications and generating a pretty little list of it and returning it. You can also pass in some arguments as well, and it does the parsing for you. Skipping down to the last one where you want to set an OTP Application Environment Key. So this is a 4-part command: set, the application name, the application key, and the value. So the application and the key, those are both atoms, because that's what they are as far as the application callback is concerned, or the kernel application. And then the value, which who knows what that's going to be. So there's a bit of magic interpretation here. It tries to guess what you're giving it. So it'll first try to parse something out to an integer, then it tries parsing it out to an existing atom, then it'll try to parse it out to a list or a tuple. And failing that, you're probably just giving it a string. So the theory here being that if you're setting an application environment variable, it's going to be an integer or an atom or a list of things. And it tries to guess what that's actually doing, or what you're actually passing it, rather. And the return syntax is fairly straightforward. It's a 3-part tuple again, OK, and then a format string and the arguments for it, or error and the format string and the arguments for it. Nothing incredibly fancy there. And then example usage of this same module is you have your custom pretty shell. You can do a shortcut into the append subshell to get a list of your available applications. Or you can bring up the actual append config shell and then edit it directly. So second thing here, listing the whatever's set in the application environment for kernel, and there's nothing really fancy there. And then actually editing a config entry, so pulling out the Thunderbeam enabled variable or environment variable for the Magicbeam app, and it's currently undefined, so we set it to true, and then surprise, surprise, it's actually true. So again, nothing too fancy there, more shortcut around commonly used Erlang apps. And I guess it's probably important to mention in the context of the included Shellbeam callbacks, it's really just meant as an example for how this callback works. So in the context of the code base I deal with day to day, it's things like starting and stopping individual components, viewing metrics, viewing information on specific customers or specific data feeds, and of course, adjusting configuration. I guess there's some shortcuts for bringing up process info and seeing which message inboxes are the most painful at the moment. So summary of Magicbeam as a whole. Kind of a catch-all project for DevOpsy bits that have been found useful in developing of Nomura. Comprised of 3 key pieces of functionality. Thunderbeam. It kills off random Erlang processes under the auspices of testing your supervisory structures. There's Hotbeam, which will reload modules or recompile and then reload source files, helping speed up that iteration process of testing stuff on the fly, developing stuff on the fly, rather. And then Shellbeam, which gives you a hopefully easy-to-use REPL shell that you wouldn't be afraid to stick somebody who doesn't know Erlang in front of, but is familiar with, maybe Cisco. So designed with ease of integration in mind. To that end, there's 2 ways of integrating it. So, of course, it's available as a rebar dependency. You can include it in release as permanent, temporary, or load-only application. If it's not permanent, there's a Magicbeam start and stop function for starting it and stopping it that just starts and stops the application. You can also inject it into a running node. So if you have an already existing Erlang project that you don't feel like stopping to have to recompile to do this, yet maybe you want to be tweaking the application environment, or maybe you want to SSH into it for whatever reason, you can do that. You can just inject it into that running node. The theory there that in our specific context was to test some stuff with RabbitMQ without having to bring it down, without having to recompile it or mess around with it. You can just toss Magicbeam right in there. And then if you're weird like me and have a fetish about configuration code, there's a callback module that you can implement that allows you to override configuration. Otherwise, it just comes out of the application environment, so command line or .config files. And then there's also going to various actions within Magicbeam will generate events, and this is the way you would catch those. So events are generated when modules are recompiled or reloaded, when processes are killed, and when Shellbeam commands are processed successfully. And these are things you can capture, and maybe you guys like audit logs. Maybe your ops team likes audit logs. Who knows? So some of the use cases that we've used it in the context of is deployment. Because like I said earlier, I want to figure out full release upgrades with Erlang, but it still doesn't quite click. So you need to determine which applications you want to reload on the fly. In our case, it's all the homebrew code, everything we've written ourselves, none of our dependencies. Create a little init script that calls Hotbeam : all, which will tell Hotbeam to reload every module that it's currently aware of within the context of the applications you've told it to care about. So generally a little module you RPC into, or Erl_call or whatever that just calls that. And you can integrate it into your deployment pipeline. In our context, it's Jenkins, and every time you click the deploy button in Jenkins, it asks you whether you want to restart or hot load. And as part of our continuous deployment action, we deploy to 2 dev environments. One of them is restarted, one of them has the hot load command issued. So we know right away, as part of every time we push changes, whether we can push this upstream to production, I guess to QA and production to be fair, without there being a problem, whether it'll actually accept those, that hot loading.
Can I ask you a quick question?
Certainly, yeah.
So do you have a running infrastructure that Jenkins talks to in like a staging environment, or do you just build everything and then?
Kind of. So our Jenkins build job results in 2 artifacts. One of them is a little shell script that we use to actually do the install. The other is a tarball. The tarball includes the Erlang VM, all of our code, config, all that nonsense. And then the deployment is a matter of SSHing into, and the deployment being wrapped in Jenkins as well, mind you. Matter of SSHing into the host you're deploying to, issuing that command, calling the deployment artifact from the Jenkins build, and passing it in the tarball of the build. I don't know if this is answering your question at all or not. What we're deploying based on is a result of a Jenkins build, and it happens just entirely within the context of that Erlang node. So if we're doing a hot load, for example, deploy, the tarball is copied over, and then we issue a command to the running Erlang nodes to hot load yourselves. And they already have in their configuration the list of OTP applications that they're supposed to hot load, and that'll then happen. If it's a restart, it comes down and goes back up.
Have you considered hot loading to a staging site?
We do that. We do that. So the continuous deployment there is where the build happens, and then it's automatically deployed to 2 dev environments, one of which has a restart happen. So everything's brought down in the right order, brought back up in the right order. And then the other one, it has just the hot load. So that kind of allows us to identify whether we're going to have problems hot loading this further down the chain. And I guess for some context there, going back to one of the to-dos on Hotbeam, it doesn't support the code change callback. So if you're changing your state, you're going to have a crash the next time a message comes in. Sometimes you won't care, depending what the gen server or whatever, depending what the process is that's going to crash. You might be able to live with that if you don't mind a little bump on a graph, assuming you're graphing that. Other times, if it's going to cause 200 workers to crash, you might want to actually restart it properly. And by doing the continuous deployment to 2 environments, that allows us to identify what's safe to push further upstream and what's not. Yeah. Does that answer? Yes. OK, cool. So another use case of this is extreme pair programming, I guess. So 2 developers, 1 editor, 1 running release, hopefully in a QA environment with people actively using it. That makes it more interesting. Every time you save a file, Hotbeam will reload it. If you want to up the ante a little bit, you can robustify your software as it's being created by running Thunderbeam behind the scenes. And then tweaking runtime configuration. Maybe you want to up timing a little bit so it's a little more, it's getting tested a little more quickly than it might otherwise. And Shellbeam gives you the shortcuts for doing that. And then the big thing for me in the context of Shellbeam, I mean, I'm not worried about doing any more damage than I could otherwise do in an Erlang shell anyway, but it's the ability or the idea of exposing some of this functionality to external ops teams. Chances are they're not going to learn Erlang. If they're going to, props. And I realize I'm making a pretty big divide between dev and ops in the DevOps track, but that's sometimes how it goes, I suppose. So they might still need to tweak knobs and levers in responses to graphs suddenly looking more spiky or flat than they normally are. Might want to give Shellbeam implementations for common operations. In our case, like I've said, it's basically configuration, scaling, and metrics, toggling individual components, dealing with things in not really a firefighting capacity, because at this point we generally know what we're doing when we're tweaking these knobs and levers. Maybe for controlling distributed components. And then there's the direct SSH access, which is, this is kind of a red herring there. You can remove those operating system distractions. Generally, they can trust that Linux is doing their thing. If they're supporting a custom app on top of that, you might not want to give them that distraction. And then a few errata around this. SSH access only supports 1 private key. And that's just kind of the way it is right now with OTP. I thought it had been fixed recently, but I guess it hadn't been. And this, I guess, gives me an excuse to make a pull request for the OTP project. Magicbeam injection requires compatible bytecode. You compile Magicbeam using Erlang R15, you're not going to be able to inject it on something running R13. And Hotbeam does not and will not ever support upgrading the Erlang VM because that sounds really, really hard. And if I'm going to do that, it's probably just going to be release upgrades, which I swear I'm going to figure out this year. 2012 is the year to do it. So that's it. There's a website up. It's open source on GitHub. Questions, complaints?
How are you detecting when the file actually gets saved or updated?
Just checking the file time.
Oh,
So yeah, which means the Hotbeam gensor tends to make generate a lot of reductions. So, but that's how it is, yeah. So, nothing fancy there. And then the metadata for everything else is available within the Beam. Any else? I hope I didn't talk too fast. Probably did.
Awesome. Thanks, Jonathan.
Okay. Thank you.